In this video, we're going to have a look at finding the median, mean, and standard deviation of grouped frequency data. So the biggest tip I'd give is always start by drawing your own column of midpoint values. So in this case, the midpoint between 140 and 150 is 145. The midpoint between 150 and 160 is 155. And then I'll just fill in the rest. I'm showing you guys now to find the midpoint between the interval. Be careful of this one because it's an interval width of 20. So you have to half it by 2, which gives 10, and you add that on to 180 to get 190. How do you then find the median height? The median height is an estimate of where the middle value of the frequency would lie. So for that, you add up all the frequencies. 7 plus 10 is 17, plus 15 is 32, plus 19 is 51, plus 9 is 60. A lot of students ask actually, do you add 1 and then divide by 2? Well, when it's group data, you don't do that. You just take the total frequency and you divide it by 2 to get 30. So what we essentially want to find is the height at which the 30th value of the frequency lies in. Let's go through how we do that. So we know that 7 plus 10 is 17. And then if you add 13 onto that, that's what gets you to the 30th values. So it goes 13 into this frequency here. Or we can say it goes 13 fifteenths into this interval. So let's write that down. It goes 13 fifteenths of the ratio into this interval here. How do we find 13 fifteenths of this interval? Well, what you do is you take how far it goes into the interval, you multiply it by the length of the interval, so 160 and 170, that's an interval width of 10. That tells you how far it goes into the interval. So I believe that's a value of 6.9. Yep, 6.9. Now that we know how far it goes into the interval, I meant to say 9. And now that we know how far it goes into the interval, we add it onto the start of the interval, which is 160. So 160 plus that 9 tells you 169 centimeters. That means that the median value is roughly 169 centimeters. Again, I say roughly because this is group data and we're assuming that everything is equally width apart. Of course, that's not true in real life. That's why it keeps saying estimate throughout this question, because it's group data. How do we use this data to find the mean height? Well, if you look at your equation sheet, you might see that the mean is equal to the sum of xf over n. What does the sum of xf mean? Well, it means the x itself represents the midpoint because there's 7 pieces of data within this range. We don't know fully whether the 7 pieces of data are geared more towards 140 or more towards 150. So what we do is we assume that they're all geared towards the midpoint, 145, and we use that as the estimate. So we use that as your x value. The frequency is just 7. And the sum just means, I'll show you how you go about doing it. Yeah, the sum just means you add together all the midpoint times frequency values that you get when you multiply midpoint of each interval by the frequency of that interval. For example, we just did the midpoint of 145 times that frequency of 7. We add onto that the midpoint of 155 multiplied by the frequency of that interval, which is 10. And then again, you're adding onto it the next midpoint times frequency value, which is 165 times 15. And you do that again and again for all the values, all the way up until the last one. So the midpoint of the last interval is 190. And you multiply onto that the frequency of that interval, which is 9. That's what the sum of xf means. And you divide all of that by the total number of variables involved, the total frequency, which is what we found as 60 before. When you put all of that into your calculator, that will get you a value of 167.9. So that's your mean value in this case. Great. Let's now move on to standard deviation. This one's a bit of a longer calculation. I'm just going to rub some of this out so we have space for the rest. Let's use a different color pen as well. Let's use this blue. Okay, so the standard deviation, again, the formula is given to you in an exam. I'm just going to quickly write it out. So sum of x squared f over n minus the sum of xf over n all squared. You might notice that this is similar to what we just did, finding the mean, and it's the same. So we can say that this whole bracket here can be replaced with the mean of 167.9. How do we find sum of x squared f? That's what most students struggle with. Like I mentioned, the x is the value of the height, but we don't know where all 7 frequencies lie, so we estimate that they all lie at the midpoint 145. So we use x as 1.145 for that interval, and we use that as the midpoint of each individual interval. So we do x squared, 145 squared, multiplied by the frequency of that interval, 7. And then this summation part here means that you add together the square of the midpoint times frequency of all of these intervals. For example, you add onto this the next midpoint, 155 squared, that represents x squared, and you multiply onto that the frequency of that interval that it came from. So that's the frequency of 10. Again, you add together the midpoint squared times frequency of the next interval. The midpoint of the next interval is 165. You square that and you multiply that by the frequency of 15. And again, you keep on doing that for all the rows until you reach the last row, which has a midpoint of 190. You square that, that represents x squared, and you multiply that by the frequency of that interval, which is 9. That will give you the value of sum of x squared f, which should be a very large number. So just doing on my calculator now. Okay, 1702575. Now we can put all of that into this equation here, and we get that the standard deviation is actually the square root of this value here, which represents sum of x squared f, 1702575. By the way, you should get a very large number here, so don't be too cautious about that. You then divide by n, which is the total number of samples that was taken, the total frequency of 60. And you take away from that the square of the mean, which is, well, we already found the mean, 167.9, all squared. And just a reminder, sum of xf over n represents the mean. You put all of that into your calculator, and that will get you a value of 13.4, which is the standard deviation for this question. Hopefully that all made sense. The key sort of takeaways is x always represents the midpoint in group data because we don't know exactly what the data is. This fancy sign here just means you add together all of these values here. So here you're adding together all the midpoint square times frequency values. Here you're adding together all the midpoint times frequency values. Hopefully that all makes sense. Yeah, I know students get confused between group data, so yeah, be sure to leave a like if this video helped and subscribe. I'll post more content like this very soon.